All right. Thank you all. Welcome to our last Happy Math Hour for the semester. So, for today's Math 2412, we will go ahead and review for your final exam review. Okay. So, let's go ahead and get started. So, one of the things that it's very important that you should be able to do and know is to fill the all these blanks on our unit circle. That way, and they make us more proficient when answering questions about angles and values for all of these angles. Okay, so let me show you how to construct the unit circle. So first, we want to divide the circle, a circle, into 8 equal parts. Okay, and when we have this is we have all our major angles for our unit circle. Okay, so we start at 0 and we're going to have these fractions or angles that are simplified. So the first ones, the first list, they're all what we call in radian measure. The second ones, as you can see, they're in degrees. Okay, so every radiant with 4 in the denominator has the point square root of 2 over 2 and square root of 2 over 2. And these are the x and y values for all of these measurements. Okay, so let's go ahead and now divide our unit circle or our circle, excuse me, into 12 equal parts. Okay. So once we divide our circle in 12 equal parts, we'll have the remaining important angles for our unit circle. Okay. So again, the first line are the angles listed in um, radians, and our second line is in degrees. Okay. So um, for your knowledge, every radiant angle with a 6 on the denominator has the point for x, square root of 3 over 2, for y, 1 half. And every radiant angle with a denominator of 3 has a point for x, 1 half, and a y squared of 3 over 2. And again, once you know this, it's very easy to determine the x and y value based on the quadrants. So let's go ahead and match these. So here is the list of all our measurements based on our quadrants. Okay. So one of the things that you may be asked on your final is to convert from degrees to radians. So let's go ahead and look at an example. So here, pi 6 is equal to 30 degrees, which refers to our point x and y point square root of 3 over 2 and 1 half. Okay, so 45 and 60. But let's go ahead and do this operation. Convert degrees to radians. So to convert any angle that's in degrees into radian form, you're going to multiply the angle by pi radians divided by 180. Okay, so let's go ahead and do an example converting 45 degrees into radians. So I am going to multiply 45 degrees by pi radians divided by 180. Okay, so this is going to give me 45 degrees pi radians divided by 180. Okay, so we can see that we want to eliminate the degrees, okay, and we're left with just the value 45 pi over 180 radians, okay. Then we want to simplify that fraction, which leaves us to pi fourths radians, okay. So let's do B, convert 60 degrees into radians. And again, our answer should be pi thirds. We're going to multiply 60 degrees by pi radians over 180. Okay, we're going to cancel out the degrees, and then we are left with 6 pi over 18 radians, and then we just simplify the values, which leaves us 2 pi thirds radians. Okay. All right, so let's do one more, converting degrees into radians. Let's convert 65 degrees to radians. Again, I am going to multiply this by pi radians divided by 180. This is going to give me 60 pi radians over 180. We cancel out the degrees, leaving us with 65 pi over 180 radians, and then simplify the values. Again, this is just to show you how I am simplifying. Um, 65 can be um, simplified by having the multiples of 5 times 13. 180 is 5 times 36. 5 divided by 5 is 1, leaving me with 13 pi over 36 radians. Okay. All right, so let's do one more. Convert 200 degrees into radians. Again, follow the same format. The degrees will cancel. We'll simplify our values. And we're going to get 10 pi over 9 radians. Okay. Um, so let's convert radians to degrees. Now let's do the opposite. Okay. So to do the opposite, again, we're gonna flip our fraction that we were multiplying to get to convert to radians. So now, given a radiant angle, we're gonna multiply this by 180 degrees divided by pi radians. Okay. So let's go ahead and convert pi 6 to degrees. So again, I'm multiplying pi 6 times 180 degrees over pi radians. Okay. Um, I'm going to simplify the values. You see how my pi over pi become 1. You all like to say that they cancel. Okay. And I'm still going to have a degrees because there's only a degrees on the numerator, no degrees on the denominator. So the degrees don't get canceled, but that's what you want. I want an answer in degrees. And 180 divided by 6 is going to give me 30 degrees. Okay. So let's do the similar for pi 4. And again, very straightforward process. Let's go ahead and do this one that's not part of our unit circle. Convert pi fifths to degrees. So I'm going to multiply pi fifths times 180 degrees over pi radians. Okay. I have 180 degrees pi divided by 5 pi. Pi divided by pi becomes 1. Okay. And 180 degrees divided by 5 is 36 degrees. Okay. Let's try another one. Pi 12ths, we want to convert the radiant angle pi 12ths to degrees. So pi 12ths times 180 degrees divided by pi radians. Our pi's become 1. 180 degrees divided by 12 is 15 degrees. Okay. So let's look at this new topic. Find the exact values of the 6 trigonometric functions of the angle theta. Okay. So here we have Um, here we have an angle. We have a triangle, excuse me, that is 90 degrees, and we want to solve for the all the rest of the angles, right, or the angle here given. So here, just to review our right triangle, the line segment between A and B is called a hypotenuse. Okay, uh, we're going to be using Pythagorean theorem to solve some of these unknown values, which is a squared plus b squared is equal to c squared. Again, c squared refers to my hypotenuse. Okay, so let's go ahead and plug in the values. The line segment from A to C, that way we can consider that little b, which is, oh, we have them backwards. It's okay. So we have a squared plus 6 squared is equal to c squared. Again, we have 64 plus 36 equal to c squared. When we add 64 plus 36 is 100. We take the square root of both sides, and we'll find out that c is equal to 10. Okay, so once we have our hypotenuse, we were able to find the 6 trigonometric functions. So just to review our labeling, okay, on our right triangle, opposite to theta, that line segment, we call it OPP for opposite, short for opposite. Adjacent to the angle is the line segment AC, and again, the line segment A to B is our hypotenuse. So just to review, our adjacent would be 8, our opposite is 6, we have our hypotenuse is 10, okay? So let's review some of our trigonometric angles. Cosine of theta refers to adjacent over hypotenuse. Sine of theta is opposite over hypotenuse. Tangent of theta is opposite over adjacent. And then we have our reciprocal or um, trigonometric functions. Opposite to cosine theta is secant theta, which is hypotenuse over adjacent. Inverse of sine is the cosecant. So the cosecant of theta is hypotenuse over opposite. And the inverse of tangent is cotangent. So cotangent is adjacent over opposite. So once we know these angles and their definitions, we're able to just plug in and give the answer. So cosine of theta, again, adjacent over hypotenuse, that would be 8 over 10, which simplifies to 4 fifths. The secant is 5 fourths. The sine of theta is 6 over 10, which simplifies to 3/5. So the cosecant would be 5/3. Tangent of theta is 6 over 8, which simplifies to 3 over 4, which is the cotangent of 4/3. Okay? So let's look at a real world application problem. We have a guide wire that runs from the ground to a cell tower. The wire is attached to the cell tower 150 feet above the ground. The angle formed between the wire and the ground is 43 degrees, and they give us a figure. So this is the figure that they're talking about here. So we have this wire here that is attached to this cell tower, and we know that the cell tower is 150 degrees, and that the wire to the cell tower forms a 43-degree angle. So let's see. They want us to find how long is the wire. So if you see, this is just like our previous example. We have a right triangle, and we want to find out the length of this wire, which is basically the length of my hypotenuse based on this right triangle. So here, this is my hypotenuse. Again, first, we want to find out how far from the base of the tower is the guy wire. So let's go ahead and we want to find the adjacent. So again, just to review our trigonometric functions, these are my angles. So what we want to use is sine of theta, which is gives me opposite over hypotenuse. And I want to use this one because I'm trying to solve for the hypotenuse, and I know I don't know the adjacent, but I know the opposite value, which is the 150 feet. So I can plug this in with the stuff that I know. Sine of 43 degrees is equal to 150 over the hypotenuse. Again, the hypotenuse is what I'm trying to solve for. So let me go ahead and solve for hypotenuse. So hypotenuse is equal to 150 divided by sine of 43. When I plug that into my calculator, I roughly get an approximation of 219.9 feet. Okay, so be very careful when you're doing your final when they ask you to round. So in this particular problem, I rounded to the nearest tenth place or one decimal place. Okay. Now, so this is the answer for A. Now let's answer B. How far from the base of the tower is the guy wire anchored to the ground? Okay, so here what we want to find out is we want to find the adjacent side, right? So we want to use is the tangent of theta. Again, why do I want to use tangent? Because I have a given side. I know the opposite, and now what I want to find is the adjacent. I know the angle as well. So you always want to use the trigonometric function with the values given from the problem. So let me plug in what they had given me. And they gave me the angle 43 degrees. So that's tangent of 43 degrees is equal to the opposite side, which is 150 feet tall, divided by the adjacent. I want adjacent. So let me solve for adjacent, plug it into my calculator. And again, I'm roughly going to get a distance of 160.9 feet. So the answer for B is about 160.9 feet. Okay. So let's look at this other example, finding the area of a sector of a circle. So for a circle of radius r, the area A of a sector of a circle with a central angle theta is given by this formula. A is for area is equal to 1/2 r, the radius squared, times the angle theta, where theta is measured in radians. Okay, so be very careful. So let's look at this example. A sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through an angle of 120 degrees, as shown in the figure below. Okay, so here's my sprinkler that is watering this fairway on the golf course, right? So they're asking us, find the area of the fairway watered by the sprinkler. So you see, what they want me to find is an area of a sector. So I'm going to use this formula. Area is equal to 1/2 r squared theta. Okay, so the first thing that we want to do is we want to convert the degrees into radians because the formula requires that we use radians. They gave me the problem in degrees, which is 120 degrees. So we know how to convert to radians. When we plug it into, when we do the operation, we have 2 pi thirds. Um, so now I have everything to plug into the formula. Area is equal to 1/2 the radius, which is um, 70 feet squared times the angle in radians, 2 pi thirds. When I plug this in, I have 4,900 pi divided by 3. Let me go ahead and use my calculator. And I'm going to get about an answer about um, 51 5,131 square feet. And again, I rounded this problem to the nearest whole number. Okay. Um, so just be careful when they ask you how to round. All right. So let's look at this one now, evaluating trigonometric functions. Given tangent of theta is equal to negative 5/4 and cosine of theta is greater than 0. They're asking us to find sine of theta and secant of theta. So we know that tangent of theta refers to opposite over adjacent, right? So we would be able to find the values for cosine and sine, but we have another piece of information that these angles that we want to find for sine and secant, excuse me, they have to be greater than 0. So what that means is that we're looking at quadrants 1 and 4. So first, that's what we need to know. We need to know the quadrants and the conditions to find R. So again, tangent of theta, as I specified, is negative 5/4. And what we want to find is what quadrant the answer that they want us to solve for. So here, do you see that tangent is negative? So it's going to be in quadrants um, 2 and 4. But the answers that they want us for cosine has to be greater than 0. So the cosine, those are in quadrants, like I mentioned, 1 and 4. So the solution that we want is going to be found in quadrant 4, which is the two quadrants that these two share. It's only quadrant 4. So those are the answers that they want us to find. So let's go ahead and calculate these values. So again, tangent of theta is y over x. So we have the x value, which is the positive 4. The y value is going to be the negative. Again, this is what allows us to have this quadrant 4 answer. Now we want to find the radius. So we're going to use Pythagorean theorem to find the radius. So that came from r squared is equal to x squared plus y squared. Just take the square root of both sides to get the radius. And let me plug in what they're giving me. So I have 4 squared plus the negative 5 squared. We have 16 plus 25, which gives me the square root of 41. So that is my radius. So now I can answer sine of theta and secant of theta. So sine of theta is equal to y over r. Let me just plug it in. So y is negative 5, r is the square root of 41. We don't like to have the radical on the bottom, the square root. So we're going to go ahead and rationalize this denominator. So we're going to get an answer of negative 5 square roots of 41 over 41. Okay. And just to quick recap, how did I rationalize the denominator? All I did was multiply the denominator and numerator by the square root of 41. Okay. So let's go ahead and find the last one. Well, I'm finding all of them actually. Cosine of theta. They only ask for sine and theta and secant of theta, but we'll do all of them. So cosine of theta, again, um, x over r. So that means that secant of theta is r over x. Again, so just plugging in, r is square root of 41 over 4. Oh, so we didn't do all of them. Just the two that, let me see, did I do the two that they asked me? Yes, so they just wanted sine and secant, and we took care of those. All right, let's look at this next example. It says finding the 5 key points to sketch one period of the sine function. So they want me to sketch one period. So one period means only one revolution. So that means from 0 to 2 pi. And they want me to find these 5 key points from my graph. Okay. And again, they're giving me a sine function. So the first thing that I need to know is that um, the amplitude. The amplitude is the value that is being multiplied to my trigonometric function. In this case, is 1/4. The amplitude is given by just the absolute value. So that means that I'm not interested if the angle was had as a reflection. I only want the value of the the amplitude. And again, amplitude refers to the radius of the circle. That's right. That's the reason why we only want the amplitude. We're not looking at a negative distance. The radius of a circle only has positive distance, right? So our amplitude is given by 1/4. Okay. To find B, B is given 1/6. But there's a formula to find B. The B is referred to the period of the trigonometric function. So let's find the period of this function given this value. So we know that B is at 1/6. And to find the period is 2 pi over B. So let's plug in 1/6 for B and solve for the period. So once we simplify this, we find out our period is 12 pi. Okay, so now let's find the key points that are based on one period for this trigonometric function. So again, what we can see here is that having a period of 12 pi, and again, if we divide our unit circle by 4, okay, we see that we have a period of 3 pi. This is our one revolution for this trigonometric function. So let's go ahead and look at the values. We have 0, 3 pi, 6 pi, 9 pi, 12 pi. Okay, so these are our terms, and let's look at our 5 key points. Okay, we have 0, 0, pi half over 8, pi 0, 3 pi over 2, and the -8, and 2 pi over 0. So let's go ahead and calculate our A. All right, so here our 1 is 0, 0. That one was given. We know that A was 1/4, so we plug that in. Again, the pi for us, we have 6 pi, which is our halfway unit from 12 pi. Okay. Then we have 9 pi, um, which is our 3/4. And then our full revolution gave us our 12 pi over 0. Okay. All right. Um, let's look at translations of sine and cosine. How we shift our graphs. And in this particular problem, we're going to see how we do horizontal translations, meaning how we can shift our graphs left and right. So we need to know the general form of both our sinusoidal graphs of sine and cosine. These are these two trigonometric functions behave similarly. Now, the other four trigonometric functions have restrictions, so we'll look at those later. But for these two particular ones, these are curves that are have no breaks; they're continuous. Okay, so let's look at sketching one period of the graph of cosine of 4x minus pi. Okay, so to do this, again, we want to find our 5 key points and then adjust our horizontal translation. So first here, our amplitude for this trigonometric function cosine is 1, means our radius of our circle is 1. B is given by 4. Let's go ahead and calculate our period. So our period is pi halves. So based on our period, we see that our period for this circle is given to be pi 8. So let's go ahead and get those major points on that period. So we have 0 pi 8, the simplified pi 4s, 3/8, and pi halves. Okay, so let's do our 5 key points again, what we had done before. And by filling in the A value for 3 and 5, we have our answers, and we are able to now graph. Okay, so we have we see that here that we are going to have a shift to the left, right? And we're going to add values of pi fours for our points. Okay, so here we have 0 plus pi fours, okay, which is going to give me pi fours 1. Pi 8 plus pi fours is going to be 3 pi 8. Again, I'm doing a common denominator for the adding of these fractions. Okay, so again, going through the list, I end up with my 5 key points. Okay, for my first point is pi 4 is 1, 3 pi 8 0, pi halves negative 1, 5 pi 8 0, and 3 pi 4 is 1. Okay, so we were able to see that we had our graph, and our graph shifted to the right. Okay, all right, and let me go ahead and place these values so you can see them. Okay, so again, we had our circle was the radius of 1. Okay, and I'm filling in my key points from my um, trigonometric function are my five key points. Excuse me. All right, let's look at another example. It says evaluating composition of an inverse trigonometric function. So it says find the exact values of the expression tan arc cosine of 2/3. So the first thing that I noticed is that they want me to find the value of tangent. Well, I know that tangent is opposite over adjacent. This is y over x. Now, inside this has to be given an angle in order for me to get this value. But that's what that word is. The arc cosine of 2/3, that is getting the inverse to get an angle, right? So this first part here, um, the first thing that we want to do is let's find out where this lies. Okay, so um, cosine um, in quadrant one is positive. Okay, so here we have cosine of theta is equal to thirds, which they're giving me a positive value, right? So this is where I get this angle, right? Cosine of theta is equal to 2/3, but the angle is equal to the arc cosine of 2/3, right? So I know that cosine is adjacent over hypotenuse, okay? Just to review, the adjacent part would be this one. My hypotenuse would be this one, okay? But they're asking me to find the tangent, which is y over x. So if you see here, I'm missing the y value, the opposite. So I'm going to use the Pythagorean theorem to find that missing value for opposite. So let's go ahead and have a squared plus b squared is equal to c squared. Again, they gave me the a, which is 2 squared. They gave me the hypotenuse, which is 3 squared. Subtract 4 on both sides. Take the square root of both sides. So we have that b is the square root of 5. So now I'm able to answer this problem. Tangent of theta, I know again is opposite over adjacent, which is y over x. So the y value is square root of 5 and the x is 2. And there's my solution. Okay. Let's go ahead and now do a different problem. Let's just solve the right triangle. So what they want me to do is they want me to solve um, the measurement of angle B, the measurement of angle C, but I already know the measurement of angle C. It's telling me that that's a right triangle, so I know that's going to be 90 degrees. But they're also asking me to solve little a and little c. Okay, so this is what they're asking us to solve, but they're giving us some of these values. So let's plug in what they're giving us. They give me angle A, which is 34.2 degrees. They're giving me angle C. Well, they don't give me, but we know that this is angle C is 90 degrees, and they give me the value for little b. Little b is 19.4. So the first thing that I need to do is let me go ahead and get the measurement of angle B. And I'm going to use geometry to solve this, okay? So in geometry, they tell us that the sum of any triangle is equal to 180 degrees. So here we have A plus B plus C should be equal to 180 degrees. So you see we're missing B. So let's go ahead and solve for B. Place substitute what we know or has been given to us, and we get that angle B is 86.8 degrees. And again, I rounded to one decimal place, so I have the answer for B. So now I'm missing A and C. So there's several ways of doing these. So what I'm going to do is I'm going to use my trigonometric functions to find these other values. Okay, so let's find A. So I'm going to use tangent of theta, which is opposite over adjacent. I know the angle of theta, which is 34.2 degrees. A is what I'm trying to solve for, but I know the adjacent, which is 19.4. Okay, so what I'm going to do is I'm just going to multiply 19.4 on both sides to get A, plug this into my calculator, and I get an estimation of 13.2. Okay, so A is 13.2. Similarly, I'm going to do the same thing to find C. Okay, I want to find C. I want to do the um, I want to find C, the little c, right? So I'm going to use cosine of theta, which is the adjacent over hypotenuse. Again, they gave me the angle cosine of 34.2. And again, please keep this in mind. You always want to use the values that they gave you because the values, if I use the values that I discovered, these are estimations. I rounded my calculator, so you might be off. So please always use the values that they give you because those are more exact to calculating the missing values that are needed or asked for. Okay. So on this problem, I'm solving for C. So the first thing that I would do is I would multiply by C on both sides and then divide by cosine of 34.2 degrees, which is going to give me 19.4 divided by cosine of 34.2 degrees. Okay. Plug this into my calculator. And again, I get C is equal to 23.5. Okay. All right, let's look at another problem. So distance. Um, we have an observer in a lighthouse is 350 feet above sea level, observes two ships directly offshore. The angles of depression to the ship are 4 degrees and 6.5 degrees. How far apart are the ships? So before we see the figure again, we always want to, when we read these problems, we want to make sure that we understand the terminology and what they're asking us. So what they're asking us, we have a lighthouse and we know that a lighthouse has a light on the top of this um, cylindrical shaped building, right? And when they're telling us that the angles of depression, what that means when I see this word depression, what this means is that these angles are looking downward to the ships, right? So let's look at the ship. So this is what we're talking about. The angles of depression here for the two angles are the 4 degrees and 65. You see that the light is looking down on these ships. So they're wanting us to first to get our solution to find out how far apart are these ships. We want to form our two triangles. You see, we have two triangles here. This is our first one, given by 350 feet with an angle of 6.5 degrees. And we're going to call this distance one. Let's get our second angle. Again, our second angle still will have a height of 350 degrees. But our new angle here is at 4 degrees. And what we want to find is now this distance too. Okay. So we're looking at an angle opposite side looking to the adjacent. So these are our trigonometric functions. I'm going to use tangent to find D1. So tangent of 6.5 degrees is equal to 350 opposite over adjacent. Okay. Solving for D1, plugging this into my calculator, I'm going to get this value, 3071.91. Okay, let me go ahead and get D2 from our second triangle. And very similarly, I did the same process. And I have this value. Distance 2 is 5,005 and 23. Okay, so the distance apart D3 and D2, we want to subtract D2 minus D1. So this is our distance D3. So plugging these in, our distance is, by subtracting these two, is 1,933.3. Okay. So again, the two ships are roughly 1,933.3 feet apart. Okay. All right, next example. Find the 150th partial sum of the arithmetic sequence. So the first thing that I also need to know when I'm reading this problem, that when they say arithmetic sequence is that I have a sequence that its pattern is governed by adding or subtracting a common value or a common difference, which is the correct terminology for our sequences. So to find the 150 partial sum, what we need to know is we need to know a few points. Okay, we want to find what our formula is to be able to calculate this. So the first thing I need to know is I know that A1 is 5, and I'm going to find this common difference term. What is the number that is generating this arithmetic sequence? What am I adding or subtracting a pattern? And of course, since the values are all positive, there's a number that I keep adding to get the next value in the sequence. So to do this, what I do is I grab the first two and I subtract a2 by a1. And when I do this, I get 11. So you see here, my common difference, and we labeled it as D, is 11. All of these points are patterned by adding 11 to each one, right? So this is our formula that gives us to find a nth term. um, a1 plus n minus 1 times d, where d is our common difference, n is the term that we want to go to, and a1, again, is the first term in our sequence. So let's plug it in. This is our generic formula. Um, Simplified, okay? And we want to find the 150th term. So we want to solve a sub n for 150. So let's plug it into our formula, and we get that the sequence value at 150 is 1,644. Okay. All right. So again, this is our values. Now, what we want to find is the problem that they were asking us. What is the partial sum? So once I got the 150th term, now I can find the partial sum. And if you see, I needed to get this last term because this is what the partial sum is asking us. We want to find the first term plus the last term, the nth term, which was the value that we just got from 150. And now we just plug it in. We want to solve for the partial sum of the 150th terms of this pattern or sequence. Plugging our values in, we're going to get that our partial sum is 123,675. All right. Next example says write the expression and write the expansion of the expression. So they want me to expand this binomial 2x minus y to the fifth power. So we have something to do this. So we call this Pascal's triangle that is going to allow us to expand very easily or more simply, because I don't know about you, but I don't want to multiply 2x minus y 5 times. That would take me a while to do that, and I can be prone to do silly mistakes with all those multiplications. So again, using Pascal's triangle, they allow me to use this formula about um, combinations, right? Can do combinations for all of my variables on my binomial. Again, so once I put it into my formula for binomial expansion, it's just simplifying all of these values, which gives me this answer. Okay. All right. So again, use the binomial theorem to write the expansion and expression. So you can better see this work. Let's go ahead and write the expansion as the expression is what they're asking us. Again, we first want to do to the 0 power, to the first power, to the second power, to the third power, to and that's it, to the third power. This one's to the third, not to the fifth. So this one to the third power. Again, my binomial expansion is going to be the combination of 3, 0, 3, 1, 3, 2, 3, 3. Again, plug these values into your calculator. The 3 choose 0 is 1, 3 choose 1 is 3, 3 choose 2 is 3, 3 choose 3 is 1. And the other ones is just using our exponent rules to simplify, yes, which gives us our expansion for y minus 3 cubed. Okay? So let's find a term or coefficient. It says find the eighth term of the expansion of 6x plus 2 pi 9. So for us, again, I'm going to use, again, my binomial expansion. Okay, this is my first, second. Um, so first we want to find r, and r is one less than the term that they're giving me. So here we want to find the eighth term, right? Because they're telling us that they want us to find the eighth term. So what I'm going to do is r is going to be 7. So I'm going to do 9, 7. Again, it's one less than the term. Okay, so here to plug it in, I have my values for my binomial term. A is 6x, B is 2y. Now be very careful also on your final when getting your A's and B's. make sure you use the sign. Especially, it's very easy to miss the b when they put 6x minus 2y. Don't just put 2y. Make sure you put negative 2y if there was a subtraction there. Okay. All right. So let's go ahead and build our binomial expansion again, and this is going to give me 165,888 x squared y to the 7. Okay. All right. Next example. Find the number of six-member committees that can be formed from a group of people consisting of seven women, eight men, if the committee must have four women and two men. Okay, so this comes from the probability section. And again, we need to do combinations again. So for our solution here, we first want to find our sample space and we want to find out what they're asking us to solve for. So here there are seven women and we need four of them. Okay, so first, um, what we want, this is going to give us our combination of from seven women. We choose four. Now, the other part is we have eight men and we need to choose two. So for this one, our combination is a given two. Okay, so again, and these we can plug into our calculator. So the combination of seven choose four is 35. The combination of eight choose two is 28. So 35 times 28 is 980. So, oops. So the product of these two is going to give us our answer for this problem. Okay. All right. Let's look at another from probability. It says a pair of dice are rolled. Find the probability of rolling a sum larger than 4, rolling a sum larger than 12. Okay. So first they are telling us that we have a pair of dice. That means we have two dice. And here is a table showing the outcome of every single possibility for the dice. So for instance, if I'm looking at the table here, the left hand corner, um, 1 1, that I on the first dice I get 1, and on the second dice I get 1, and respectively for all. So these are all the possible outcomes that I can get from rolling the two dice. Okay, so first I get my sample space, and I know my sample space is that each dice has six faces. So to get my sample space, I use the um, um, I just multiply 6 times 6. Um, and to get 36. Okay. Um, and so this is my sample space. So I'm going to use this formula for probability. Probability is equal to the um, event divided by my sample space. So now they want me to find the sum larger than 4. So with this table, it's very easy to see all of the values that I have larger than 4. Okay. Um, so again, continuing are all of these, right? So when I see is that I have 30 possible combinations that give me a value larger than 4 when I roll out these dice. So this is my event of happening. So this is my N of E. Okay, so plugging it in, N of E is 30, my sample space is 36. Simplify this fraction and I get 5 6. So the probability of rolling two dice and getting a sum greater than 4 is 5 6. Let's look at B. Rolling a sum larger than 12. Again, very similar. My sample space doesn't change. Oh, and I remember the word. I found my sample space by using the counting principle. The counting principle says that the number of possibilities are multiplied for each possibility. So each dice has a possibility of having six faces. So 6 times 6 is 36. And that's where I get my sample space. Yes. So here we go. We want to find the sum larger than 12. And again, it's very handy to have a table like this to be able to get all of the sums greater than 12. Okay. So here we see that 6 plus 6 is the largest face that we can have on the dice. So 6 plus 6 is 12. So we're never going to have a sum greater than 12. So our sample space is here 0. And I'm sorry, my event is 0. My sample space is still 36. So 0 divided by 36 is 0. Okay. All right. Next example. Find the standard form of the equation of the parabola with the given characteristics. The vertex is 6, 3, and focus is 4, 3. Okay. So this is what we need to know. So we need to know what our vertical and horizontal vertices are. Again, these are the formulas given for us. Okay, so these are the vertices for vertical axis and horizontal axis, 1 and 2. Again, for this we see that for the vertical, the H repeat; for the horizontal, the K's repeat. So here we have that the K's repeat, right? So what we're looking at is we're looking at a horizontal axis uh, equation. So it's the one on the right. So our vertices are 6, 3, okay, and then vertices, these vertices refer to our H and K. So having our H and K and giving our focus is 4, 3. So again, this is the value that it came from H plus P. Again, the K's stay constant. Okay, so solving for P, we get P is equal to -2. Now we can plug it into our formula. So our formula is y minus 3 squared is equal to 4 times -2 times x minus 6. Let's clean this up a little bit. And our standard equation of the parabola is given by y minus 3 squared is equal to -8 x minus 6. So you see here, also just to review visually our transformations, this graph got shifted 6 units to the right, 3 units down. And 3 units up, excuse me. And it's given by a vertex. So it's positive 6, 3. Yes? All right. Let's do the next one. Find the center vertices and foci of an ellipse. Then sketch the ellipse. So here they gave us the ellipse in standard form. So to put it into what I call our vectors form, we're going to have to complete the square for the ellipse. Okay, so here, before I start completing the squares, I'm gonna rearrange these terms so you can see how we can complete the square. So I'm gonna combine the x's with the x's together, the y's with the y's, and then I'm gonna move the constant to the other side. Okay, so now you see here on these two parts. Before I start completing the square, I also want to make sure I simplify or factor any of the x or y terms. So you see here for the x, for the coefficients, there's nothing for me to factor because I have a 1 and 6. But for the y's, I could factor the 4 and 8. They both have they share a value of 4. Okay. Now let's go ahead and get the missing c part that I have here. So again, completing the square for the x squared plus 6x is 9. So how did I get this value 9? I divided 6 by 2 and squared it. 6 divided by 2 is 3, and 3 squared is 9. Okay, let's get the c value for the y. Again, I'm going to get -2. -2 divided by 2 is -1, and -1 squared is 1. So I need to add 1 here. So if I added 9 on the left, I need to add 9 on the right. But let's be careful. I'm adding a y, I'm adding a 1 to this equation or quadratic that is on my horizontal, the y, but I had factored out of 4 before I did that. So the true value that I'm adding is not just 1, but I'm adding 4. That 4 times 1 from that factor value that I had there before. So if I simplify this, okay, I have this value, x plus 3 squared plus 4y minus 1 squared is equal to 4. But again, our formula for vectors form, we need to, it's to be equal to 1. So what I'm going to do is I'm going to divide by 4 on both sides, and it's going to give me now the uh, the correct term that they wanted. X plus 3 squared over 4 plus 4y minus 1 squared over 4 is equal to 1. And having it in this format, I'm able to answer the rest of that they're asking me. So it's easy to see here that my center got shifted 3 units to the left, 1 unit up. So my vertex here um, is again using the formulas, but let me skip through these. I don't like to use the formulas. So I know that my h is -3, y is 1, okay, my a is 2, my b is 1. To calculate c, I'm going to use my Pythagorean theorem to calculate c. The formula is given by c, well, it's somewhat Pythagorean theorem. C squared is equal to a squared minus b squared. That's why I said sort of. Okay, be careful on this formula when finding the ellipse. Okay, the ellipse has a minus between the a squared and b squared. Let me plug in what I have to be able to get my c value. Take the square root, and c is equal to square root of 3. Okay, so now I'm able to answer everything that they asked me. So this is my center. These are my vertices. simplified. Okay, these are my focus, and I can sketch my graph. Okay, all right. Let's find the standard form equation of a hyperbola. Okay, let's skim through this quickly so I make sure I get through the whole review. Again, we did these last week, so I'll just skim through them really quickly. Again, based on the information that they're giving me, I can easily find by my formula the missing values. I can find the value C. Again, you see here for the hyperbola, it is like the Pythagorean theorem. It is C squared is equal to A squared plus B squared. Solve for B squared because that's what I want to solve for. So I get B is the square root of 5, and it allows me to give the standard form of the equation of the hyperbola. Okay. And again, just a little bit of simplifying. All right. So this might be, I think, three more points to cover for your final. So this particular problem says convert the polar point -2 7 pi 6 to a rectangular point. So I understand when they're giving me the polar point, that first value refers to the radius and that second value refers to the angle of the polar coordinate point. So to get the rectangular point, we have some formulas. To get the x value is r times cosine of theta, and to get the y value is r sine of theta. Again, they're giving me everything to solve for this. So r is -2, theta is 7 pi 6. So again, if I'm looking at the angle that refers to this point here, we're looking at that it's that 210 degrees, which is y is negative square root of 3 over 2 negative, and for x, and y is -1/2. So again, plug in these values in, you'll see that we're gonna get these points. Okay, so we're able to plug them in and solve for the rectangular point based on the radius -2 and the angle 7 pi 6, which is square root of 3 and 1. Okay, let's do this one again. No, let's do the opposite now. Convert the rectangular point, -1 and square root of 3 to polar point. Okay, again, I need to find the quadrant that r and theta lie on. So here we have -1 that's shift to the left, square root of 3 is up. So we're looking at is in quadrant 2. Yes. So here, let's go ahead and first find r by using our trusty Pythagorean theorem. We're going to use theta to find our angle. So again, this is my point. Again, this point lies in quadrant 2. So we need to add pi to the arctangent of theta. Okay. So let's go ahead and find r. R is the square root of 4. The square root of 4, r is 2. Tan of theta is y over x, which is the square root of 3 over -1. Let's take the arctan of this. And when we do the arctan, we get negative pi thirds. But again, because we're in quadrant 2, we need to add pi to this. So we're going to do 3 pi over 3. So minus pi plus 3 pi over 3 is 2 pi over 3. Okay. So our polar point is 2, our radius, and our angle is 2 pi over 3. Okay. Oops. Oh, that was my last one. Excellent. With 5 minutes to spare. So does anybody have any questions? Excellent. I want to thank you all for joining us. I want to wish you the best of luck in your finals. Hopefully, this quick, brief representation of your final can help you out. Again, if you missed it, please. Um, my presentation will it was recorded and it'll be uploaded later on our YouTube channel. So again, I wish you the best of luck, um, and we'll see you next semester. Thank you all.
Thank you, Mr. Carrizales. Thank you, everyone, for coming in today. We wish you luck on your finals. See you for summer.